All right, in today's lesson, we're going to take a look at the idea of integration by parts. So with integration by parts, you take a integral that is very difficult to solve, and by using the technique of integration by parts, you can make it easier to go ahead and integrate. So the general formula for integration by parts is as follows. The integration by parts relationship is the integral of u dv is equal to u times v minus the integral of v du. This relationship here is related to this question, for instance, in that we have to choose a value of u and choose a value of dv in such a way that the end goal is this integral right here is easier to take and an integral you actually can take. You'll notice this initial question here, the integral of this is very hard to see what that would be, and we're hoping by using integration by parts we can break this down, and using this relationship we now have a much easier integral to integrate. So the idea here is, what do we want to let u equal and what do we want to let dv equal? There is not a set technique to identify what you want u to equal and what you want dv to equal, but you need to choose it in a way that this resulting integral is easy to calculate. So let's go ahead and identify some substitution options. And you'll go ahead and see here, I let u equal x cubed plus 2x, the entire expression to the power of 2. And then I let dv equal dx. You can see here by combining these two things together, you're taking your u and your dv, u dv. I get the exact question we started off with, but I know I can calculate what v is easily. So that's one thing you have to make sure you do, is that the dv value you choose, you have to be able to actually take the antiderivative here, in this case v equals x. And you have to also be able to take the derivative of your u value. In this case, we get the following. So now I'm going to go ahead and substitute this all into my equation, giving us. Substituting this all in here, we have our integral of u dv, and you can see it does reproduce the initial question, is equal to u times v. We have our u and our v, minus we have our integral of v, which is right here, that's my x value, and then this expression here is all du. And we can see matching that from above. So substituting that all in here, we have the following. So now our new challenge is to be able to calculate the integral of this expression. So to go ahead and do that, you'll notice now we are in a situation where I had this on as a power of 2. I don't have that power of 2 here anymore. So we can just expand this whole thing out and apply our integration operation linearly, giving us the following. And you'll notice here in the following two steps, the first thing I did was I went ahead and took the product of these two binomials together. I went ahead and expanded and simplified them out in this step. And then the next step, I went ahead and distributed that 2x into this. Now this is 4 terms and simplified. So now we're in a situation where we only need to calculate the integral of this expression. This becomes an easy task because you can apply your integration operation linearly to each one of these terms separately. Doing so, we get the following. Applying that integration symbol linearly to each one of these, we end up getting the integral of 6x to the power of 6 is the following. The integral of 4x to the power of 4 is 4/5 x to the 5th. Likewise here and here, went ahead and applied that integration symbol all the way across. And don't forget, we put a plus constant here because we are taking an indefinite integral. I'm going to go ahead now and we're going to distribute this minus sign into this expression and expand out the following so we can simplify. And you can see here I went ahead and took our binomial that we're squaring and I expanded that out, and then I distributed the x value into that, in this case, this trinomial here. And then we also went ahead and distributed the minus sign into this expression, giving us the following here. Simplifying, we end up getting our final answer as 1/7 x to the power of 7 plus 4/5 x to the power of 5 plus 4/3 x to the power of 3 plus our constant term c. So this is an example where integration by parts comes into play here, where you can take a question that can be very difficult to integrate, and while the math here was a bit tedious, a lot to keep track of, we did eventually get to the final answer. Let's take a look at another example using integration by parts. So in the following example here, we want to calculate the integral of x e to the 2x plus 1 dx. And again, you notice here that direct integration is very difficult. I cannot think of an expression such that its derivative is x e to the 2x plus 1. So in this case here, we're going to go ahead and do this using integration by parts. I went ahead and let u equal x and dv equal e to the 2x plus 1 with respect to x. Doing so, I could easily calculate the antiderivative of v. And then I can go ahead and take my derivative of u and get du equals dx. You can see here, right here is our focus, and we want to make sure, can I calculate the integral of this? Because again, that's our main idea here. You remember this ends up being uv minus the integral of v du. So we want to be in a situation where I can actually calculate this integral, and you can see here that's just a product of these expressions here. And this can be integrated fairly easily here. Using our integration by parts formula, we get the following. So you can see here, substituting this in, this is the integral of u dv, which is exactly the original question we had, is equal to u times v. And you can see our v value here is substituted in, minus the integral of v du, and we have exactly this value here. So substituting this in using the integration formula, we have the following. And our main goal here is now, what is the integral of this value right here? You'll see here the integral of 1/2 e to the 2x plus 1 is just going to end up being e to the 2x plus 1 divided by 4. The reason for that is the derivative of e to the 2x plus 1 is itself, times the chain rule kicks in. You have to take the derivative of your exponent here, the 2x plus 1. The derivative of 2x plus 1 is 2. And the 2 divided by 4 gives us our half here. So the integral of this expression is as follows. Going ahead here, our final answer is 1/2 x e to the 2x plus 1 minus 1/4 e to the 2x plus 1 plus that constant value c. All right, that concludes today's lesson on integration by parts. Future videos will be posted with more examples using this integration by parts technique. Thank you.